Thanks for coming today. We're excited about this presentation. We're going to be talking about next generation firewalls and what you need to know about managing and selecting them. All right, let's jump right in. All right, what is a firewall? A firewall is a network security system designed to prevent unauthorized access to or from a private network. So there are four main dimensions to a firewall. We've got separate security zones. It enforces policies, adds security, and polices traffic. So that is key. Those are the basic functions. So additionally, most firewalls will also do network address translation. That's almost a given these days. But these four things are kind of what I would consider the requirements to call anything a firewall. All right, firewall timeline. Firewalls kind of started around 1989. So that was Jeff Mogul of DEC, so that's Digital Equipment Corporation. He came up with what was the first packet filter. So at that time, there weren't any firewalls, and it was a mechanism just to protect one network traffic from getting from one network to another. So a year later, it was Steve Belkovin and Bill Chesawick of AT&T Labs. So that's now Lucent Technologies. So they came up with the firewall that did stateful packet filtering. So in that situation, it's looking at the session of the TCP/IP or UDP session and making a determination whether to let traffic flow. So a couple years later, there was a Gen 3 firewall, and that basically combined those two technologies together. So in 1994, Checkpoint, which was kind of a leader in firewall technology, they came out with the first graphical user interface. So we'll talk more about that in future slides. But that was combined by some products from Squid and Snort. So those are some what were open source utilities, and they've now morphed into commercial products. So. All right, so continuing the firewall timeline, we have 2004. So that was the introduction of UTM, Unified Threat Management, and we'll talk quite a bit about that later in the presentation. Performance was a key problem there, and it's because computers and systems weren't that fast, CPU and memory were expensive, and to do that full Unified Threat Management and inspect those packets at that level, that took a lot of resources. So that impacted, especially in high performance environments. So let's jump up to 2008. Palo Alto, they came out with what was generally considered to be the first next generation firewall. At least they're the first company to use that language in their marketing literature. So and it was an impressive product. They were definitely a market leader. So 2009, Gartner, so they basically went further to define the next generation firewall as something that involves threat intelligence that comes from outside the firewall. So that could be a cloud or a collection or a large database. We'll talk more about that, of course, as well. So next generation firewalls today. They're merging into the cloud, cloud-based services. They've integrated with data analytics and integration with enterprise workflows. So those are key, and we'll talk about those all in detail here. So network protocols. What is a network protocol? So for the most part, the world runs on IP. That's the internet protocol, TCP/IP, UDP, we all know and love. But not exclusively. Those are not the only protocols around. There are other protocols out there. So legacy protocols are still in use and available. Why is that important? Well, if your firewall is only focused on TCP/IP, then it's not going to be able to properly filter, detect, or block some of those legacy protocols, which could be a threat. Maybe you want to block those if they're in use. So you need to consider those when you're talking about network security. So here's some of the network transport protocols. We've got AppleTalk, Bluetooth, BACnet, Internet Protocol, of course, Novell, IPXX. I see we've got a few people that remember those protocols, so that's great. The OSI protocol suite, that's more of a model. rather than an actual implementation. Again, we'll talk more about that in detail. IBM SNA, I know we have a few people here that remember and work with that. And then USB. And that's just the common technology to connect a peripheral to a computer. But it is a legitimate protocol that can be an attack vector. So the question is, how do we block against that? And is that traffic that our firewall needs to support as far as monitoring and blocking? Okay. So we're going to talk briefly about the OSI protocol stack. Why? The OSI is an important model. It was developed in the 70s. It basically highly modularized the communication between all the different levels in computer networking protocols. So some people say it was over-engineered, and the market got to vote, and they basically kept TCP/IP. So the industry never adopted OSI or moved to it because TCP/IP was already so entrenched. But having said that, a lot of vendors still refer to the 7 layers of the OSI, especially in firewall industry. They'll say, look, we protect all 7 layers. When they say that, they're referring to the OSI stack, not TCP/IP. Okay, so let's jump into TCP/IP. So that is the Internet Protocol Suite. Everything on the Internet, for the most part, is based on that. It has many different protocols, TCP/IP, UDP, ICMP, and there's a full listing of those at the IAANA website. So basically anything that can traverse an IP packet is an IP protocol. So kind of important foundation just for the rest of this talk. TCP/IP has individual ports, as does UDP. So there's 65,536, which is 2 to the 16th power. So if you are a service listening on TCP/IP or UDP, you bind to one of those ports and you're listening for incoming connection. So there's more than enough for anything a single server will do, and most of the lower numbered ports are predefined to have a specific purpose. And we'll talk about that here in the next slide. So OSI versus IP, so here are the 2 protocol suites kind of lined up with each other. Why is that important? Because people kind of talk about things in reference to the OSI stack. So you can see the Telnet, FTP, SMTP, they're all kind of in the application, presentation, and session layer. The transport is TCP/IP or UDP, network is IP, and data link and physical are kind of merged together in Ethernet, token ring, or FTDI, or if you have a WAN interface. That's all kind of the below the network layer. Common IP ports. So this is a listing, it's more of a sampling of just the more common IP ports, both TCP/IP and UDP, that people connect to. So we've got port 21, which is FTP. We've got port 23, which is Telnet. 25 is SMTP, that's email. 53 is DNS, and 80 is web traffic, as most of us know. So why is this important? So basically, these are conventions. So when somebody loads these programs on a server, bring up a web browser and you type in a website, it defaults to port 80. It's because most websites serve on port 80. It's just a convention. But you could easily run a web server and have it advertise on a different port, port 22. Of course, you would have to type in 22 at the end of the web browser to connect to it. You're kind of overriding the default. So it just underscores that just because these are the conventions, from a security standpoint, you can't assume that a certain traffic on a certain port is going to be that protocol. It's arbitrary. So IP version 6. Let's talk about that. So right now, most of the internet is operating on IPv4, but that is changing. IP version 6 is becoming gradually rolled out. People are adopting it, and it's out there. So there are ways to achieve that interoperability. We're not going to get into the technical underpinnings of that here, but I know some of the people in this room are struggling with that, and it's a challenge. So they're working to go through that. IPv6 support. So it doesn't change anything above the network layer. TCP and UDP run the same, applications run the same. It's basically abstracted. But below that, some things are different. So the difference is the glue between the network and the transport layer. So IPv6 addresses are typically dynamically assigned. Sometimes they can be, they'll use your IP version 4 address and then as a beginning, and then use your MAC address and tack in some bits and bytes on that, and that combination will be your IPv6. Or there can be a DHCP server that hands it out with a combination. So I've run into this before where we use Qualys scanning tools, and I wanted to scan the IP version 6 for one of our large clients. And first of all, the Qualys tool didn't have that feature enabled by default. I had to call Qualys support, and we've been using Qualys for years. I'm like, we want to use IPv6. They're like, okay, here's what, we've got to turn it on for you in the cloud. So they did that. Great. So now I said, well, I want to scan this range. I said, well, you can't scan IPv6. You have to basically manually enter every system that's running IPv6 and put its address in and associate that with the IP version 4 of that system. I'm like, you're kidding me. The point of it is I don't know which system's running IPv6. I don't want to go hunt that down. I want the scanner to tell me. Can't do it. So that was kind of enlightening. Okay, what is a firewall? Is a switch a firewall? Is a router a firewall? Is a server a firewall? Is a wireless access point a firewall? A mobile hotspot? The answer is it depends. What is it doing? All these things could be firewalls or have some firewall functionality. So none of these really qualify as a next generation firewall, and we'll get into what those features are. So we're going to rip through the formal definition of the Gen 1, Gen 2, Gen 3 firewalls here, and then we're going to get into next generation. So packet filtering firewalls. So this is the legacy. This is basically the first firewall. All it did is allow and deny list based on the packet header information. Pretty basic. No awareness of session or state connection. They were very easy to maintain, manage, fast and efficient, operates at wire speed. Does not inspect data, effectively operates on a blind trust model. Meaning if you match my source IP and my allow destination IP, I trust you completely. You pass. Okay. The things in blue are basically what's different from the previous slide, just for a little aid there. So with a circuit level gateway, and these are kind of legacy terms here, they will allow sessions initiated from a trusted network. They will monitor packet headers for a valid TCP/IP handshake. That handshake means they're watching the session. They know the state of the session. They trust all traffic for an established session. If you're a trusted device and you've initiated a connection to something else, it's going to trust all the traffic coming back. And they operate on a, again, blind trust model based on the source of the session origination. So if a trusted device started that communication, everything from there, that point's trusted for that session. Stateful packet inspection. So most modern firewalls you get today at least have this capability, except maybe home routers, perhaps. So they combine both of those, packet filtering with TCP/IP session awareness. Now, they're more resource intensive, and they can have a performance impact at high load. Okay, proxy firewalls. So now we're getting into some of the more advanced stuff. Technically, I would not call this a next generation firewall, but this effectively acts as a man in the middle. So if I'm doing an encrypted session, I will bring up a browser with HTTPS. I've done a security exchange. Let's say I'm doing banking. So my traffic is encrypted from my browser to the bank, and the bank decrypts it. So if I'm using a proxy, that server is basically pretending to be the system I'm talking to, and it's doing the decryption, and it's re-encrypting it, and then talking to the bank in that scenario. So the fact that it's doing that, it can see all the unencrypted traffic as it passes through. So then it can look at that and make a determination, is that data safe? Do I allow it? What type of protocol is it? So that's deep layer packet inspection. So this is, as you can imagine, more resource intensive. If you're sending a lot of traffic through a proxy server, it can have a performance impact. So it can offer significant protection when implemented correctly, and provides a single system for full visibility. So just a sidebar here. So some of these, less than free countries out there that are trying to manage all the internet traffic that's coming in and out of them, they have at a minimum these proxy servers. So basically, any encrypted traffic can't go out of some of these countries without the powers that be knowing what's in that channel, right? Okay, UTM firewalls. So this again is a precursor to what I would call the next generation firewalls. And the biggest differentiator I would say is basically that, we'll get in the definition on the next slide, that UTM firewalls don't necessarily leverage cloud intelligence to enhance their capabilities. So they're basically doing deep packet inspection and might have some dynamic capabilities and heuristics, but they're kind of a standalone box. Okay, next generation firewalls. This is why we're here. Most modern firewall vendors tout their products as next gen. So we're going to kind of dispel some of that FUD. There's not much consensus of what makes a firewall truly next gen. According to Gartner, it is a deep packet inspection firewall that moves beyond port protocol inspection, blocking to add application level inspection. And the key is it brings intelligence from outside the firewall. So what does that mean? So we're going to get into a laundry list of features that I have identified that I believe may have any of all of these to be a next generation firewall. So frequent real-time threat signatures push from a centralized source. So actually, let me stay with that. So a lot of the leading firewalls, Fortinet, Palo Alto, Cisco, you can subscribe to cloud-based services where they have huge analytics engines. They're looking at the threat landscape across the internet, and they're saying, we found some important signature-based items that we're going to push down to your devices. So that is a common feature in next-generation firewalls. So integrated IDS, IPS focused on both vulnerability and threat-facing signatures. So IDS, IPS is intrusion detection and intrusion prevention. It's this web URL filtering service is tightly integrated. And we'll kind of get into that integration and why it's important. Botnet detection based on known CNC, so command and control systems. So a firewall should be kind of have a lot of these botnets are basically known what IP addresses are doing their command and control, and what protocol and channels are using. So if you had an infected system in your environment and it's communicating or being a slave to one of these control system botnets, your firewall should detect that. Replacement for your edge router. We're seeing more and more clients that don't even have a router. They basically, their firewall can run OSPF, BGP, do all kinds of static routes, and have multiple connections coming in and handle that, what was traditionally a router function. Full protocol stack visibility and application identification. So by that, if we go back to those port numbers, so if somebody's transmitting SSH or HTTP, but they're using a different port, your firewall shouldn't just trust that it's, say, oh, it's HTTP because it's port 80 or 443. It's going to look at the format of the traffic and correctly categorize it that way. Ability to generate and issue and push out security certificates to endpoints for seamless proxy operation. So one of our clients is a school district in Texas, and they have 44,000 students. And they wanted us to turn on basically deep packet inspection. So that means we had to generate a certificate in the firewall and use group policy to push it out to all the end devices. And so when somebody brings up their computer and goes to encrypted website, basically the firewall is giving them a certificate they trust, and it's decrypting the traffic and then re-encrypting it and sending it to where it goes. That works great except for Apple. And another option is the ability to enforce policy independent of port and protocol. So if you want to block a certain application, it's not doing it by the port it's using, it's basically doing it on the application signature. So continuing the list. Integration with Active Directory services, either LDAP, NIS, X500, or Active Directory. And we'll talk about what that integration means in practice. Able to map user accounts to systems and network activity for event and security correlation. So sure, I see that there's an IP address, but I want to know what user that IP address is tied to. Who's using that IP address? What's that user behavior? Can make suggestions based on IPS activity. So it's seeing activity. It shouldn't just be a reporting mechanism. It should be saying, raising its hand and saying, hey, Mr. Network Operator, you should be doing XYZ. This is something that I think is key, and this is going to be a future of most firewalls in the enterprise space. They control and take action on network infrastructure in the administrative domain. So by that I mean, if your firewall is communicating with your switches and your wireless access points, and it's seeing a rogue device or some device that's been compromised in your network, it can shut that switch port down, isolate that system, or quarantine it. So now and then, the system administrator can go and investigate, but it can't do any more damage, right? Once it's been detected that it's at risk. So it operates on trust metric levels, not absolute trust. Meaning, do I trust a device or not? It's never a yes or no. It's what's the threat level. And that can change at any time based on the behavior of that device. So your domain controller in your environment, if it starts talking to other devices and sending protocol traffic that hadn't happened in its baseline operation, something's changed. So maybe somebody loaded some new software, or maybe not. It depends how intelligent your firewall is to make that distinction. But the trust level for anything can change based on a number of heuristics. So then that's right into the next point. Heuristic analysis dynamically modifies the trust level based on network traffic. It may collapse security management of many devices into one interface. Is your firewall basically the central control for other aspects of your network infrastructure, your switches, your access points, other firewalls? Can you manage them all from one pane of glass, one device? On subscription expiration, this is more of a sidebar, but next generation firewalls, most of them will continue to operate in a basic, policy. I allow this network, but not this network. The more advanced, intelligent features might stop working, reporting, but they won't just become a brick, right, if you stop paying your subscription. That's something I look for when I would consider putting a firewall in our client environments. Full-featured published APIs. So a lot of large companies, they want to basically integrate their own custom applications into their firewall, either make calls to make changes or pull data out, and you do that through the application programming interface. So that could be REST or XML for custom application development. I think that's pretty important. The ability to ingest third-party information feeds or feature expansion. So there's a lot of companies that will provide third-party feeds. So let's say a trusted list of IP addresses or an untrusted list of bad actors. And that list is constantly changing. So you can subscribe to that. And so it's just like your spam lists. So if anybody's ever gotten on a blacklist for spam, you know how hard it is to get off. But that's an example of a list that you subscribe to and everybody just uses it. The ability to cluster for high availability or horizontal scalability. So I think that's important. Basically, high availability means active. You've got 2, 3, 4 firewalls. They're distributing the load. One goes down, they can shift, and just like a server cluster. So inline configuration allowing transparent network implementation. So if anybody's heard the term a bump on a wire, so basically it's a device that you put in between your network link and it's completely transparent, meaning it's not, each network leg doesn't have a different subnet. It's looking at traffic coming in and it sends it out the other side unmolested, and the other devices can't tell it's on the network, but it's actively monitoring that traffic, inspecting it, and if need be, blocking it. So bolt-on data analytics, applications showing security baseline and anomalies. Tighter integration with SIEM offerings by the same vendor. So that's pretty common. And then trending features, machine learning, Usually that will be part of a SIEM offering. So now you're talking about kind of big data and analyzing it. You wouldn't necessarily need to have that in your firewall, but your firewall should play nice with those type of SIEM systems, feeding it data in the right format and being compatible in general. Okay. Generation 4. Progression of firewall technology. So this is just kind of a review. We started with packet filtering, allow, deny based on IP, stateful packet inspection. Hey, if you initiated the packet, I trust you and everything coming back to you. Proxy UTM, they do man in the middle to provide application layer and deep packet filtering. And then next generation, basically that's our cloud intelligence with all the features we just listed, potentially, some combination of them. Okay, what are the challenges with next generation firewalls? Architecture, integrated inspection pipeline. So early vendors would kind of kludge their modules together. Hey, we have a piece of software that does this, does that. We'll just kind of load them all together and they don't really work together. And that runs into performance capabilities and things are just clunky. And if you ever go to one screen, it gives you certain information. You go to another screen and it conflicts with what you thought you saw on the other screen. That just tells you your firewall wasn't well architected and isn't an elegant implementation. Throughput. So everything we listed there, that takes a lot of CPU, a lot of power, a lot of algorithms are doing all that. So if you turn everything on your firewall and it's doing everything in software and not using ASIC-based hardware to accelerate those operations, you're going to bring it to its knees in pretty short order. So performance becomes a real issue. Best-in-class systems implement logic or ASIC chips rather than software. So ASIC is basically, instead of the software, it's put on a chip, which is much faster. And software-based next-generation firewalls can't take advantage of ASICs. So a lot of vendors, Palo Alto, Fortinet, you can basically take that same firewall and run it in software or buy an appliance and run it in hardware. And it's the same features, that same interface. But if you're running in a VM, you can't take advantage of that ASICs. And I could see a future where so many firewalls are virtualized that a firewall vendor may say, hey, we're going to give you an extra card or blade that you can put in your VMware stack or Hyper-V and offload some of the things that would normally happen in software and take advantage of that ASIC. So another challenge, I think, is ease of use. I've used a number of firewalls, and they can, because they're such complex devices, the interface can be difficult to use, and you don't really have context about you're modifying an object, and it's not clear what that object's relationships are to other devices in the firewall. So if I'm evaluating firewalls, these are kind of the key things that I would rank them by. And so while SIEMs and a lot of other log analyzers do bulk of the security event pipeline analysis, a good firewall at least be able to give you some basic information about where the major threats are that you need to be acting on as a firewall administrator, right? SSL decryption. So at high speeds, onboard SSL decryption can be quite a difficult process unless you have multiple next generation firewalls clustered. So again, it depends on the performance and the hardware capability of your firewall. So lack of support for non-TCP/IP protocols. This is a pet peeve of mine. So there's a lot of firewalls, and they're so IP-centric. And there's a few that do support non-IP protocols, but that seems to be a kind of unspoken and undiscussed issue. So they do exist. They're used in corporate environments. And you can actually tunnel one legacy protocol through another. So you could tunnel an old protocol through TCP/IP and kind of hide that traffic from a firewall. OSI 7 layers, just a quick review again. Don't need to cover that. So risk is where you aren't looking. So TCP/IP, IP filtering, again, that's what most firewalls are focused on. Here's all the other protocols that can basically be a vector to infect your system. And as Gordon just helped us understand, the Intel AMT is a very good example of that, right? And I would call that a combination of in-band and out-of-band management, because in-band, it's using your same NIC card, but out-of-band because the hardware is separate from your hardware architecture. So USB protection. USB is a network protocol. Do we need to be worried about that? Do we need to have security for that? Certainly. USB is an infection vector for a lot of systems. So there's two main ways that I know to deal with that. One is basically if you're in a corporate environment, you can basically do a network policy to lock down USB storage devices. That's, if you want to hear 1,000 users complain, turn that on. Your phone will ring. If you have to have USB capability in your corporate environment and you can't accept the risk, there are commercial products out there that basically act as a USB firewall. You plug them into your computer, plug an untrusted device, and you've got that layer of protection. Bluetooth. Who here runs Bluetooth in their car and uses their phone? And man, brave. Okay. Anyway, they should be on the radar. If you're talking about firewall technologies, I mean, that's Bluetooth traffic can traverse over the same network that you've got IP traffic on. So many next generation firewalls can detect and police Bluetooth traffic, but only if it passes through the firewall, right? If it's going straight from your mobile device to your computer, then your firewall can't touch it. Firewall deployment models, pretty obvious. We've got hardware, software, host space, OS integrated or third party. So this is basically in an operating system. Hypervisor, mobile, container. We won't get into containers much, but transparent on the wire. So Windows firewalls. Windows has its own firewall. I used to beat them up a lot more than I do now. They've made pretty good strides as part of their entire ATP, Advanced Threat Protection. So if you're in a large corporate environment, it needs to be part of your security concentric protection strategy. So, and this is not a next generation firewall, but it's useful capabilities to round out your security profile. You can get a little technical here, but so recently we had to, we were doing some syslogging on some of our clients using a Linux server, and basically we wanted to run syslog, and we were testing it, and we were running this Logstash and listening on port 514, which is syslog. Everything's working great, and we decided to put it in production, so we're going to run the program as a non-privileged user. Guess what? It couldn't bind to port 514 because that's a protected port. So that's kind of interesting to know. A lot of server operating systems will protect those lower ports just because they're considered well-known or a little more trusted, which they shouldn't be, really. I mean, all ports should be equally untrusted. So this is interesting. VMware Micro-segmentation. How many people have heard of this or are familiar with that? Okay. So protecting virtual machines in a virtual environment has always been a big problem, because the firewall can't really see what's the traffic between those virtual machines unless you VLAN it out and extend those VLANs to the firewall. And the traffic leaves the hypervisor cluster and then passes through the firewall and goes back into the cluster. Well, that's inefficient, performance impact, and it kind of defeats some of the advantages of having everything in a virtualized cluster. So VMware has basically got this micro-segmentation where they have security policies that they can wrap around individual virtual machines within their VMware cluster. And you can even do vMotion migration and move a VM from one cluster, one host to another, and those rules will follow that attached NIC. So that's kind of a key security technology that a lot of large data centers are adopting. So there's challenges, and there's companies out there that are trying to solve them. So that should be, if you're in the data center space or heavily virtualized, that should be on your radar. Okay, we're not endorsing anybody's company right now, but I'm going to talk about Fortinet because I'm familiar with it. So I think it's a good example of what they're doing in the next generation space. They have integrated security fabric, full UTM with IDS, IPS, threat intelligence built into the interface, integration with Active Directory. They manage multiple devices as part of their for fabrics, which is in wide area wireless APs, vulnerability scanning of the environment, and risk scoring. So I've got a few screenshots of that. And cyber threat assessment learning report. So they kind of check a lot of the boxes that we talked about earlier. So this is a screenshot of basically the menu of the Fortigate for one of our clients' environments. And I've hopefully obfuscated the name of the client here. If not, let me know. So I put red arrows here kind of on, again, some of the major check boxes of, so under FortiView, which is kind of a module of a little reporting engine within the Fortigate interface. So you can report on threats that it's observing in your environment, both from the internal LAN and from the WAN. And you can look at endpoint vulnerabilities and a threat map. And I've got a couple screenshots there. You can do an audit of your security fabric, which is very helpful when you're faced with a compliance, or an audit and you're subject to compliance. The firewall basically acts as a controller for your Wi-Fi. How many people have dedicated Wi-Fi controllers in their environment? Used to. Okay. So this is a general trend where a lot of security devices are now they're becoming the controller. So that functionality is collapsed for good reason, because you want to have that security functionality in a central location. Security profiles. So this is basically where you set your policies and profiles for intrusion prevention, data leak prevention. So DLP, sometimes that's called data loss prevention. You're basically controlling what sensitive information goes outside of your environment. Let's say you're a bank or what have you. You don't want anybody to email credit cards or financial information. You know, the firewall can look for that data in the data pattern and block it if you turn it on and configure it properly. Hitting the wrong button here. There we go. Application firewall, Fortinet compliance profiles, proxy options. Proxy, again, being that deep packet inspection. SSL, SSH inspection, that's kind of a separate module. And then user device, single sign-on, LDAP server, so that's where you integrate into Active Directory. Rogue AP monitor, so that's kind of nice. Typical capability you find in a wireless controller. Hey, tell me what other rogue devices are on the network so I can track them, hunt them down, shut them off, what have you. And then log settings. So we're going to get into that here in the last slide. So yellow. Okay, we have a pretty picture. This is a device map showing the type of operating system and a bubble map for the amount of traffic. So it's more and more firewalls are giving us intuitive information that we can quickly assess. Hey, are all these servers, these are all mostly Windows servers, are they kind of all the same? Which one should I be focused on or aware of? Well, the one with the larger number, that basically is sending most of the traffic. So great, I know that. I can easily discern that just from the images. The same kind of thing here in these different VLANs. And this Prober 4. And it shows you how much, 163 gig and 76 gig. You can't see it here, but this is on a 24-hour cycle, so you can change the timeline. 15 minutes, an hour, 24 hours, whatever. So quickly get an assessment. Where's my traffic coming from? Who's sending it? Oh yeah, these are all different VLANs.
Can you set up things such that you can detect large amounts of data exfiltration, say, after hours and on weekends?
Yes. On my last slide, show you how we do that. So this is the same map, except we changed the drop-down instead of traffic to be the threat score. So now these bubble sizes, instead of the traffic, they're showing us how trusted or untrusted that device is. So how useful is that? And so basically you click on it, and this happens to be this device here, and it's telling me that's a domain controller, and basically that's its threat score.
The bigger it is, the less, the more of a threat it is?
It is big, the bigger it is, the higher its threat score. So then you can drill down and look in the logs and make a determination, but you've got an idea of where you can focus your time on. Same device map, but with threat size and details. Okay, so stepping back, this is basically Gartner's Magic Quadrant, which compares both Quadrant for enterprise network firewalls and unified threat management. So we got Palo Alto Networks, Checkpoint, Cisco, Fortinet, of course. The same players. Sophos is here as the leaders as well. So we've worked with all those firewalls. They all have a role. They all do a good job in some areas and maybe have challenges in others. But if you're in the enterprise space, that's what you're going to run into. So I stole this slide from Fortinet. You probably recognize it, Terry. Slightly changed. But so this was why it was interesting. It kind of mapped out the Generation 1, Generation 2, Generation 3. It stopped at 2010. I mean, we're at 2019 right now. So it's just the curve of where things are going, I guess, which is up. Is that more difficult or more expensive? We don't know. Both. Okay. So these are all the check boxes. If you've got a next generation firewall, you should be checking most of these, I would think. So, and I'm going to post this on our website, so we'll have anybody can download the slides. So this is the last slide. Basically at Freedom, we are getting heavy into security analytics. This is a screenshot of our dashboard in our managed services NOC as of this afternoon. And we're breaking it down. So basically, we've got about a dozen client firewalls, and we're ingesting all that traffic into our central data center, into Elasticsearch stack. And we're using Kibana to basically analyze that and look or hunt for those threats. So Gordon, to your point, basically this is a stacked graph by warning, by errors and alerts of our firewalls, of all our firewalls over the last 24 hours. So this breaks it down, a stacked graph of just the errors broken down by client, which we have whited out here. And then here, this is the alerts, which are the most severe. These are usually active attacks. These are usually configuration errors. And so these two panels give us the details of in reverse chronological order. So basically, what do we see there? PHP dice scan. So that is a known attack that has occurred from this public IP to this internal IP. The packet was dropped, and then that is a web link to Fortinet's website that talks about the details of that attack. And so our security analysts get this in real time. If they see a spike or something that's out of, if the packet wasn't dropped, or it's a server that we wouldn't expect to get hit, we can click on that and start the remediation right away. And these are basically web filter blocking. So people going to Spotify or what have you. So this other panel, we're breaking it down by service, and it's stacked over time. So most of our traffic is DNS, and if we see anomalies here, so to your point, Gordon, if somebody's exfiltrating traffic, might use a common protocol like DNS, or they might use something else. Either way, we're going to see a spike in our traffic. And our team kind of knows what to expect on a daily basis and volume based on clients, but we're looking at activating the machine learning aspects of the system, so that's automatically going to establish a baseline and let us know if something goes out of that normal baseline.
Are these just all based on firewall syslog?
This is just firewall syslog traffic. We're also ingesting Windows event logs, but we've got another panel for that. But the session's about firewalls. And then traffic alerts by client, and then by source IP. So this is a dynamic board, so you can click on one of these and filter on a certain service or client, and all the other panels update with that filter. So anyway, that's it. Is there any questions? Go for it.